Here we discuss the solution of a problem from the section Binomial Theorem and its applications. This problem has appeared in JEE main exam held on 22nd July 2021 in the afternoon shift. The example is the number of elements in the set consisting of n belongs to the set consisting of 1, 2, 3 up to 100, which satisfies 11 power n greater than 10 power n plus 9 power n is. So we have to find the number of elements n from this set consisting of 1 to 300, which satisfies the inequality 11 power n greater than 10 power n plus 9 power n. Solution: 11 power n greater than 10 power n plus 9 power n is if and only if 11 power n minus 9 power n greater than 10 power n. We write for 11 10 plus 1, for 9 10 minus 1, and raise them to the power of n and apply binomial expansion and simplify. This is if and only if 10 plus 1 whole power n minus 10 minus 1 whole power n greater than 10 power n, and apply binomial expansion for both of them and simplify. The first term and the third term, fifth term, they cancel off, and you will remain with the second term, fourth term, and sixth term, etc., and 2 times of it. This is if and only if 2 times nc1 10 to the power of n minus 1, this is the second term, plus nc3 10 to the power of n minus 3, plus nc5 10 to the power of n minus 5, plus etc., greater than 10 power n. And nc1 is n, and 2 times is 2n into 10 to the power of n minus 1. We will separate that and we will write the remaining as one term. So that is if and only if 2n into 10 to the power of n minus 1 plus 2 times the remaining terms greater than 10 power n. Now what we see is if you substitute n is equal to 1 here, 2 into 1 into 10 to the power of 0, that is 2. And this, there is no contribution from this when n is equal to 1, because 1c3 has no meaning. Therefore, there is no contribution from these terms, and that will be 2 greater than 10, which is not true. Suppose you take if n is equal to 2, 2 into 2, 4 into 10 to the power of 2 minus 1, 10, that is 40, and no contribution from this is greater than 10 square. That is not true. And n is equal to 3. If you substitute, this is 6 into 10 square, 10 square. And for when n is equal to 3, there is a contribution 3c3, that is 1. And 10 to the power of 3 minus 3, 10 power 0 is 1. And plus 2 will come, and no contribution from the remaining terms. Then 6 into 10 square plus 2 is greater than 10 cube is not true. Suppose you take n is equal to 4 in this, 4 into 2, 8, 8 into 10 cube, 10 cube plus contribution 2 times 4c3 is 4 into 10 to the power of 4 minus 3, 10, and no contribution from here, and you will get this is greater than 10 power 4, which is not true, So that means this inequality is not true for the values n is equal to 1, 2, 3, 4. Let's see what happens when n is equal to 5. If n is equal to 5, then it will be 2 into 5, 10 into 10 to the power of 5 minus 1, 4, plus 2 bracket 5 c3 10 square plus 5c5, no other terms. Then you will get 10 into 10 to the power of 4, 10 to the power of 5, here 10 to the power of 5, plus something here on the left hand side. Therefore, it is certainly greater than 10 to the power of 5, which is true. For n is equal to 5, it is true. Now, if you see, for n greater than or equal to 6, what happens? 2n is greater than 10, strictly greater than 10 for all n greater than or equal to 6. When n is equal to 6, 2 into 6 is 12, 12 greater than 10. From there onwards, n greater than or equal to 6, 2n is greater than 10. Therefore, 2n into 10 to the power of n minus 1 is greater than, 2n is greater than 10 into 10 to the power of n minus 1 is 10 to the power of n. So 2n into 10 to the power of n minus 1 is strictly greater than 10 to the power of n without taking any of these terms, remaining terms. So this inequality is true for all n greater than or equal to 6, and anyway n is equal to 5 is also true. Therefore, the above inequality is true for all n greater than or equal to 5. So from 5 onwards, the inequality is true. The inequality is true for n is equal to 5, 6 up to 100. From 100, for the first 4 terms, the inequality is not valid, and for the remaining it is valid. Therefore, for the 96 numbers from that set satisfy this inequality. Therefore, the required number of elements is 96. Therefore, our answer is 96. That is the discussion of the solution of the problem from the section binomial theorem and its applications, wherein you have to check whether the given inequality is true for from a given set of numbers. So for how many numbers of that set this inequality is true is to be discussed, and that has been done, and I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.